2 a.m., a production dashboard glows red. Alter table flashes like a warning sign. The table holds 300 million rows. The change looked innocent, and now the CEO is in Slack. The old playbook stopped the app, run DDL, pray collapses at scale. In a rolling deployment, version A and version B share the same database simultaneously. Expand contract solves this. First expand, add the new shape, like a phone new column while the old column stays. Traffic keeps moving, then validate. Finally, contract, drop the old column. Every intermediate state is backward and forward compatible, so any step can be rewound. You change the tire at 70 miles per hour, no locks, no outage, no panic. Adding the new shape is only half the battle. Both schemas must hold the same data, or users see different answers depending on which version they hit. Dual writes do exactly that. Inside one transaction, the application writes the same row to both the old table and the new table. But not every writer goes through your app. Cron jobs, integrations, and legacy scripts can bypass it. That is where trigger-based synchronization comes in. Database triggers catch those writes and copy them across. Both paths must be idempotent safe to rerun and guarded against recursion, so a trigger never fires another trigger forever. Old and new stay locked in sync without stopping the world. Now the new schema exists and stays in sync, but you do not cut traffic over yet. Instead, you prove it with shadow reads. Every real read still goes to the old schema and returns the user's answer. A hidden copy of the same query runs against the new schema in the background. A comparison meter logs mismatches and latency, but never touches the response. Meanwhile, backfill copies historical data into the new shape in small, idempotent, resumable batches. If a batch fails, you rerun it safely. No long locks, no user impact. You fix discrepancies now, before a single real request depends on the new schema. That is validation in production without the risk. Only after shadow reads and backfill prove correctness do you flip the switch. The pipeline has 4 steps: expand, sync prove, flip. Cutover means reads and writes now go only to the new schema, but the old schema and its data remain intact, faintly visible in the background. That is why rollback is one flip away. If latency spikes or counts diverge, you snap the toggle back from new to old. The data never left. Just remember, a rollback plan you have not tested is a fantasy. Always rehearse it in staging before you touch production. Write it down. That is how you refactor a database without downtime, without the 2 a.m. nightmare.